Yes, in the last class we discussed about what is meant by a transient and what are the reasons for occurrence of a transient and what are the types of the transients. And in today's class we are going to see the traveling waves on the transmission line. So let us assume this long transmission line is a lossless line. The meaning of lossless is, so the magnitude of resistance in the series impedance is 0 and conductance in the shunt branch is also 0. Thereby, out of these four elements called as R, L, C, G, R and G values are 0. Thereby, the transmission line is modeled with only two elements called the inductance, this inductance L, C, followed by again L, C in each sections. Like that, we have to divide the entire transmission line into number of sections. In each section, we will formulate the transmission line with only two elements called energy storing elements, the inductor and capacitor. So LC network, it's a ladder network, LC ladder networks. Then let us see how the voltage and currents are traveled from sending end side to the receiving end side against these energy storing elements. So this is the sending end port. If you observe, these two ports are the sending end ports, and other side this was the receiving end port where the load is connected in general. In between the sending end and receiving end, it is formed with a ladder network with L and C, if you observe like this. So whenever the voltage is imposed or whenever the voltage is impressed at this sending end side, then directly or instantly we can't observe the voltage on the receiving end side because there are energy storing elements. So this energy storing elements will take some delay, like because the property of this energy storing elements we all of us know. Inductor acts as an open circuited condition, whereas capacitor acts as an short circuited condition whenever it is subjected to immediate voltages. So the inductance, whenever this acts as an open circuit, so in order to have the voltage transformation from one section to the another section, first of all this capacitor has to be fully charged, then only the voltage will be applied to the second section. First, immediately let us assume instantly at a starting point the voltage is injected at this sending end side called V voltage. So it will take some time for the inductor to charge. So after closing this inductor, then the capacitor starts charging. Whenever the capacitor starts charging, then whenever it gets fully charged, the amount of this fully charged voltage will appear for the second section. So on like that happens for the third section and fourth section. Finally, the load will have or the voltage will be available at the receiving end side. So the properties are inductance acts as open circuit and capacitor acts as a short circuit. Because of those natures, the voltages and currents doesn't instantly move from sending end side to the receiving end side, where we can observe in the next slide with a well-known example. So in general, we can formulate each section of the transmission line in a physical representation in our real-time application, that is the tanks which are cascaded. Let us assume there are three sections of a transmission line which are shown to understand in a clear way, easy way with a tank and water filling example. So three sections are there in the transmission line representation, means we assume that there are three tanks which are connected cascading. Okay. So the height of the tank here, if you observe the height of the tank, this height of the tank is nothing but the capacitance. If you check it here, the height of the tank is nothing but the capacitance. Then here the main source acts. The main source acts from here. What is this main source? The main source is nothing but, in our example, the water tap. So whenever the valve is opened, then the water starts filling the tank by tank and reaches to the third one. So it will take some time. Whenever we immediately open the valve of the tap, no, the water doesn't flow directly to the third tank, if you check it. So the same holds good for our electrical circuit also. In a transmission line, whenever the sending end side voltage is switched on, the switch is turned on, like the valve is opened. Whenever the valve opens, no, the water starts flowing. Like that, whenever we close the switch, then immediately the voltage and current doesn't travel to the transmission line and will reach to the other side. It will take some time. So let us see, the height of the tank in our example acts as a capacitance, and next filling of the tanks stage by stage indicates that there was a path for the water flow. So whenever the valve is opened here in our example, then the water first starts filling the tank 1, tank A. So whenever this tank A is filled, then obviously the meaning of the filling of tank is nothing but charging the capacitor C in the first section. So whenever the capacitor gets fully charged, then it acts as a source, or it creates a path for the next section. The meaning here, if you observe, the water, if it is filled in the first tank A, then only because of this channel provided here, cascading connection between the tanks, the water will have a path to go into the tank B. In the same way, here also, if and only if this first capacitor gets fully charged through the charge allowed by the inductor, then only the voltage will be applied for the second section. The same thing holds good from the second section to third section, where in our example we can correlate with the filling of tank B will creates a path for the tank C. Okay, in the same lines, finally it will reach us to the destination. So whenever there is an obstacle at one point of the tank during the filling of water, if I keep an obstacle at here without allowing the water, then you can observe that the water will come back, right? So the movement of the water comes back at any instant. If you calculate the volume of that water, no, then it will be the sum of the entered water and returned water altogether. Whatever the quantity is available, we can tell that much amount of liters is available in that tank. In the same way, whenever the voltage is impressed on this sending end side, then slowly with the help of this inductor, the capacitor will start charging. It will give the supply. For the next section and so on. If any obstacle happens at middle of the points or at the end point, okay, because of this obstacle, the charge flow called as current, and also the voltages that are impressed step by step will reflects back in a similar way how the water has turned up back, no, like that. Here also the voltage wave or the current wave which is traveling in a forward direction smoothly will happen until there is no disturbance. If any disturbance is there on the transmission line, like a joint. What is a joint? So the overhead transmission line having certain characteristic impedance. In the last class we discussed that characteristic impedance will be in the terms of hundreds, 400 ohms. If such a characteristic impedance overhead transmission line is jointed with a cable, the cable is having only 40 ohms. So because of the joint means there is a disturbance in the ohmic value. Okay. So because of the disturbance in the ohmic value, obviously the reflections will start, the voltage and current will start, it's reflecting the values. So this happens on the transmission line whenever it was moving from sending end side to the receiving end side. So with this concept we came to know that the total traveling wave on the transmission line is due to the forward wave and reflected wave at any point. So at any point it is equal to the sum of forwarding wave, are also called as incident wave, and reflected wave. Reflected wave is also called as backward wave. The summation of these two waves is called as a net traveling wave.